Hello world, it's Calcutron here with the 14th episode of our TI Basic tutorial series. In this episode, we're going to be working more with lists and learning about some of the different operations that we can do on lists. So let's go ahead and we'll start by creating a new list with just 1, 2, 3, 4, 5 in it. And we'll store that into list 1. Now, in order to access all the operations or all the commands or all the functions that we're going to be using in this episode, we hit second and then stat, and stat has the second function of being list. So here we can see all the names of the lists we have created. So if we had made any lists with custom names, like we saw in the last episode, they would show up here below our L1 through 6. And then if we go over 1, we get to the ops menu or the operations menu. And then if we go over 1 more, we get to the math menu. But today we're just going to be working with the ops menu. And I think that this math menu, if you understand the mathematical concepts, is pretty easy to understand. However, this operations menu, if you aren't familiar with these operations and how to use them in the syntax, you're going to want to learn about them because they can be pretty useful in your TI basic programs. So we're going to start at the top just like we did when we explored number operations, and we're just going to go down through this list and learn almost all of these commands today. And if not today, eventually we'll cover all the useful ones. So we'll start with this, sort A, and what that stands for is sort ascending. So for this, what you do is you pass it in the name of the list you want to sort. So L1 is what we want to sort. And then it says done. So this does not return a sorted version of the list. It doesn't evaluate to a new list. It actually modifies L1. So now if we look at L1, it didn't actually change, which is kind of funny. But if we store something like 6 into L1 at 1, and we take a look at L1, now it's not sorted, and if we run this again, sort A of L1, and we look, it is back in sorted order. Now this is sort A because it's sorting in ascending order, so 2 ascends, it gets larger to become 3, so on to get this. And then you can probably guess what sort D does, but if you can't, what it does is it sorts the list in descending order. So sort A for ascending, sort D for descending. Now our next command, our next operation is dim, which is short for dimensions. So it will tell you what are the dimensions of a list. So if we pass in list 1, we can see that the dimensionality has 5 elements in it. Now, in the last episode, we talked about how you can grow a list by storing 1 greater than the highest index. So in this case, our highest index would be 5, and if we wanted to, we can do 7 stored into L1 at 6, and if we check the dimension, now it's actually grown. However, we said we know how to grow it by 1, but we don't know how to shrink our list, and we don't know how to grow it programmatically. And so I'll just show you what I mean by grow it programmatically. And that would be if I just want to say I want to add 8 onto the end, I want to grow it by 1 element, you would do 8 stored in L1, and we know that it's going to be L1 at 7, but if there were more or less elements, greater or fewer elements in the list, then it would be a different number. So we do 1 plus the dimension of list 1, and this will always grow our list. So if we hit this a bunch of times, it's going to keep growing, and if we look at list 1, we can't see all of them, but if we look, all of those 8s we just added are back. Now let's say we want to shrink our list back down, we want to get rid of all these 8s. Well, you can actually store into the dimension of a list. So the way you do that is you find what do I want the new dimensions to be. So let's say we want them to be 5. and then you can store that into the dimension of the list. So it's kind of a weird way to use a function, but the calculator allows us to do this. And if we look, now the list has shrunk back to 5, and we can store 3 in instead. And if we look at our list, it's shrunk down to 3, and it's taking things off the end, of course. And now if we want to grow our list by more than 1, let's say we want to go back to 5, we can do that, and it will fill in zeros for the new elements it's created. So we have 65400. Alright, so that has been dimensioned, so we can use that to check the dimensional list as well as change the dimension of the list. Our next one is fill, which will fill our list with one value. So right now it's a bunch of different numbers. If we wanted to make those all the same with one command, we could do fill, and then the first argument is what we want to fill into, or what number we want to use. So let's fill it with the number 12. And then we want to fill that into list 1. So the list is the second command. We run this, and again, like sort, it does not return a new list. Rather, it modifies the list that we passed in. So now if we look at L1, it is filled with 12s. So that's pretty straightforward. Our next command is probably the most useful one we've seen so far, besides maybe dimension, and that is seek or sequence. And you'll see this will differ based on what operating system you're running. On the one I'm running, which is 2.55 MP, it's going to give us a nice dialogue type thing in order to set the different parameters to our seek command. And that seek command again stands for sequence. So it's going to give us a new list using a formula we provide, using an expression we provide, and filling it with values from that expression. It'll be a little more clear if I show you. The expression we're going to use, let's say we want to get a list of numbers from the function x squared. So we could do x squared as our expression, and we're going to want to use the variable x, and we want to start at, let's say, 1 and end at 5. And if we hit paste, it puts that command out, and then if we hit enter, we can see that it's going using values of x from 1 to 5, incrementing by 1, and it's setting the value of the list it's creating to an evaluated version of the expression we passed in. So it's x squared evaluated from 1 to 5, stored in a list. So you'll notice this resembles greatly a for loop, and like a for loop, we can also change the step. So we can go from 1 to 5 in the steps of 2, or we can go from 5 to 1 in steps of -2. So it works very similarly to a for loop, except it's creating a list. It's similar to a list comprehension. And this is one of the most useful commands. So if we just wanted a list of the numbers 1 through 5, we can just have our expression be x, and we'll get x from 1 to 5. Or if we want from 2 to 15, we can get a larger list. Or if we want to have it sequence values from another list, creating a sublist, if we still have list 1 and we wanted to make list 1, let's use the sequence command to make list 1 something that is desirable, so from 1 to 5. And now, if we had our list and we wanted to get a sub list out of that, what we could do is we could come in here and we could say sequence L1 at x as an index from 1 to, or let's say from 2 to 4, and we would get a subsection of our list L1. So it's just L1 from 2 to 4. So you might imagine there's a lot of different uses for seek. So that's a good one. If you're going to memorize any of the commands and really commit yourself to using them, they would be dimension and probably seek or sequence. And then maybe the next useful I would say is augment, but we'll get to that. So the next command is cumsum, which is short for cumulative sum, and what this does, if we can just test it passing in L1, and it's going to do a cumulative sum of the values in L1 and create a new list. So if you look at L1, L1 started as 1, so the sum starts at 0, and it reads element by element and adds that to a running total. So it started with 1, or it started with 0, and for the first element it added the first element of our list to its running sum, so it added a 1. For the second element it added a 2, so the running sum is now 3. For the third element of our cumulative sum list, it adds the third element of our list, which is 3, so our cumulative sum is now 6. And it keeps going like that through the whole list. So this one can be useful when it's paired with other commands, but I don't find myself using it too often on its own. But if you're doing statistics, often you want to do a cumulative sum of some table of data. Our next command is delta list, which is kind of the opposite of a cumulative sum. And I'm just going to type, well, we can use this. So our delta list is going to tell us what is the difference between each element on the list. So L1, you'll remember, had 5 elements. And if we look at the dimension of our delta list of L1, it only has 4. So it's taking and it's comparing every adjacent element in L1. So it's comparing the 1 and the 2, and it's finding their difference, and the difference is 1. And then it's making that part of the delta list. So delta list of L1 is going to be 1, 1, 1, 1. Delta list, here's something that's kind of cool. You can obviously compose some of these functions over each other, and so I didn't mention this, but the last couple commands, so seek, cumulative sum, and delta list, unlike fill and sort, they don't change the list. As we've seen, L1 has stayed the same after we've done all these operations, but they return the answer, so we can compose them in a more intuitive way. So we can do the delta list of the sequence of x squared from 1 to 5, and you'll notice something kind of cool, and that is that our first difference of an x squared function is this 3, 5, 7, 9, 11. And if we started at 0, it'd be 1, 3, 5, 7, 11. And you'll notice, if you know calculus, that the difference list is highly related to the derivative. And so this list 1, 3, 5, 7, 9, 11 follows the line 2x, which you know is the derivative of x squared. So that's kind of a cool thing we can do by combining the functions we've learned so far. Now the next function, which I think I said was useful, is 9. So we're going to skip 8. The select is for doing things with plots, so it's not quite as useful. But augment does something called concatenation. And concatenation just takes one list and sticks it on the end of another list. So it's sort of like adding those lists together or combining them. In programming, you might call that concatenation. So this augment function takes 2 lists, and I'm just going to type our lists outright. Well, I'll use list1, and then for our second list, we could use list2, but I don't believe we've defined list2 yet. So I'm just going to use a new list. It's going to be 10, 11, 12. And when we run this, we get, so like the past couple of commands we've been seeing, it returns a new list, and it's our L1, which is 1 through 5, and then concatenated onto that is the second parameter to augment, which was a new list we created 10, 11, and 12. So it's combined those into one. And so we saw earlier, if we wanted to add a single element to a list, we can do that element stored in the list at 1 plus the dimension of the list. We saw that this would add a single element to the list. So it used to be 1, 2, 3, 4, 5. Now it has an 8 on the end. We can also do that through augment. So we can augment L1 with a new list containing only that new element or containing more elements. So a new list with just a 9 in it. And we can do that. If we want to change L1 though, we have to also store the result of that into L1. So now L1 has been augmented, or we've concatenated, or we've pushed a new element onto L1. And we can do that over and over, like we saw before, and L1 has a bunch of 9s at the end. So let's just double check, but I think that's all of the different list operations we're going to go over. So if you have any questions or comments, please leave them below. Otherwise, I hope you enjoyed this episode and I hope you learned something. Bye-bye.